Okay, we're going to be having an exam on Wednesday, and so I thought what I would do here is just spend a little bit of time reviewing some concepts that are important to the exam. And I can think of about 4 things that I think you need to focus in on studying. The first thing is certainly distributed loads. Okay, you'll definitely want to take a look at how to do that. Make sure that you can handle rectangular, triangular loads, know what the equivalent force is and where to put the equivalent force, because I can tell you distributed loads will show up somewhere on your exam on Wednesday. Okay, so be able to handle those, which leads into the next topic, of course, and that is equivalent loads. Equivalent loading. That is, if I give you some distributed loads, or maybe I don't give you any distributed loads, or I give you moments or whatever, you need to be able to take a bunch of different loads and create one equivalent load. Okay? And you definitely want to study that. Another thing that's definitely going to be on there is some kind of 2D equilibrium problems. Okay? So basically we call it 2D statics. Chapter 5, okay? This is the homework that you had due last week, okay? And that's the homework that, hopefully you put a lot of time into, you studied it, you know how to do it. You also had a quiz last week covering 2D statics, okay? And in that case, what we're doing is we're doing some forces x equals 0, some forces y equals 0, and some moments about some point is equal to 0, okay? That's 2D statics, 2D equilibrium, okay, chapter 5, okay? Obviously, these first 2 things were really mainly from chapter 4, okay? And finally, there is the potential of, well, there's a couple more things, really. There's 3D statics that could come up as well, okay? If I do a 3D problem, I've got to make it fairly simple, okay? And I can tell you that I have done that fairly simple for the 3D problem. If it does come up on the test, I think it's not going to be something that involves a whole lot of complication. Now, we did some 3D problems in lecture. Some of them were more complicated than others. And definitely review your homework, okay? This is where you've got to look at the homework that you have due this week, okay? You have homework due Tuesday night, the night before the exam. Review that 3D statics homework. Make sure you know how to do that going into the test, okay? And the last thing is, don't forget about 3D moments, okay? And that's something that you want to make sure you know how to do. R cross F, make sure you know how to do that as well, okay? I really think I've designed this test to be very easy and straightforward. I hope you believe that when you take it. And so what I thought I would do now is I've got a few example problems that I'm going to go through. I'm not going to go through all the details and all the problems, but I thought what I would do is at least kind of go through it a little bit with you, and I'll go ahead and send you this as well, so you'll have this in an email as well, so that you can take a look at this. So, okay, this is just kind of an example exam. I've got 3 problems. Okay, this doesn't cover everything. These examples don't cover everything. You definitely need to study those things that I gave you on that first page. Okay. So in this first problem, it says calculate the moment of force F about the OP axis, okay? The OP axis given like that, okay? And so the moment about that axis, all right? Now, in order to get the moment about an axis, it's similar than getting the moment about a point, but then there's one more extra thing. So let's talk first about getting the moment about a point. Okay, you know how to do this. Getting a moment about a point, okay? You do R cross F, where R is a vector Can't spell today. Vector from the point you're doing moments about, to any point on the line of action, okay, on the force's line of action, okay? So, and then there's one more thing you would do in this thing, okay? Because in this case, I'm not saying a point, I'm saying the axis, okay? So to get a moment about an axis, or an axis, okay, you still do R cross F, okay? And in this case, your R, okay, that particular R, you don't have a point now. If you're doing a moment about an axis, you don't have just one point. You've got infinitely many points, right? Okay, so in this case, you choose any point on the axis. Okay, so remember that. Choose any point on the axis for that one. And do R cross F. But that's not it. It's not just R cross F. Okay, you also have to dot that with a unit vector in the OP direction. Okay, you've got to do the dot product with a unit vector in that direction. Okay, and I believe, let me go back here to your equation sheet. I believe I may have given that to you, maybe not. Okay, I do have the, yeah, it's not there, but I do have the projection, but I don't have that other one with the moment. Okay, but it is basically, you just dot it with a unit vector in that direction. Okay, so that's not too hard. Okay, so in this case, what you would do, all right, is you already got force F. This is nice and easy because in this problem you got force F as a Cartesian vector, so that's easy. You're done. Okay, and so if you wanted to get the moment of force F about the OP axis, you just choose any point on the OP axis. Okay, well, you could choose P, but I think it's easier to choose O. All right, and so your R then, let me draw it up so you can see it here. Your R, if you're in this particular example, you would just go from O to A. All right. And so that's going back 3, so it's minus 3i. You're going to the left 7 minus 7j, and you're going up 4. So there's your R. Okay? So your F's given, your R is given, and then all you have to do is do the R cross F. I'm not going to go through the math of that. You should be able to do that. Make sure, if you have a calculator, then you know how to do this. Okay? Because I have a pretty strong feeling you're going to do an R cross F on this exam somewhere, okay? Or I guess do it some other way, but I think it's probably the most convenient. So do it. Make sure you know how to do that. And then this last step of dotting it with a unit vector in the OP direction. Remember, you got to remember how to make a unit vector, okay? You got to remember how to make a unit vector in the OP direction, okay? That's not that hard to do. You got to go from O to P, right? You got to figure it out. You look at this and you go, okay, well that's 4i plus 6j minus 2k, right? And then you divide out I its magnitude, 4 squared plus 6 squared plus 2 squared. Okay? So that's not too bad. So that's a quick review of the first problem. Second problem here, replace the distributed load, one equivalent load, and specify its location measured from B. Okay, we've done this. Again, it's not new. Looks just like what we've done before. Maybe we did exactly this problem. I can't remember. We might have. Whatever. Okay, so we got this here. You got a load there. You got a load there. You got a load there. Right? Okay. And so what you've got here, remember this load here is going to be 1/2 the base, 12 times the height, 800 pounds per foot, okay? Do the math, 4,800 pounds, okay? You know, this one's 1/2 the base, 9 feet times the height, 300. Yeah, I think we've done this problem before, so I apologize for that. Probably should have come up with a different problem, but it's fine. Just review this, okay? You've got to review distributed loads, okay? I promise you're going to see it somewhere on the test, okay? Make sure you're ready, all right? This one is going to be a rectangular load of 9 times 500. And remember that to get the specified location measured from B, the equivalent load, what's the equivalent load? Well, add them all up. Some forces in the y direction where up is positive, well, they're all going to be down, whatever. You know, you're going to get some negative number here, right? Add them all up. That's the equivalent load, but where do you put it? Okay? Where do you put it? Well, some moments about B. Okay? Some moments about B, that will equal, when you have that one force, it'll equal the same moment about B that you have from the distributed load. Okay? So know how to do that. Okay? It's coming. Somewhere, some shape or form, you're going to get a distributed load somewhere. Okay? All right. Finally, I just kind of chose a new problem here. You're definitely going to get some kind of 2D equilibrium problem. I thought about putting this kind of problem on a test. I thought maybe people get scared by the spring, but in this case, the spring is really irrelevant because it just asks for the force at A. Okay, in fact, you read the problem, it says the brake pedal has a 350 Newton force applied at the bottom and is shown. Calculate the force in the spring at A and the pin at D. Okay, so what you've got there is just a force in the spring, so it doesn't really matter that it's a spring. It really doesn't matter. It doesn't have anything to do with the problem. You don't have to use any spring equations or anything like that, okay? So you got a free body diagram. That's critical. You're going to need to do free body diagram for the exam. Okay, got some kind of thing like this. Doesn't have to look perfect. Okay, something like that. You've got here the x, the y, 350 Newton force, a 20-degree angle, all right? And then you've got some kind of force here. Now, you don't know necessarily which way to do the force. Like the spring could be in compression or tension. You don't really know. Just take a guess. I'm going to guess it's this way. Call it force F. You do the statics to work it all out, okay? Probably the easiest thing to do is pick a point where you have a bunch of unknown forces, okay? Once you've identified your free body diagram, pick a point that has a bunch of unknown forces. To me, that's point D. And do a moment equation, okay? Because if you do the moment, in this example, you do the moment about D equal to 0, you can solve it. What do you got? Well, you got F times 50 millimeters. If you want to keep it like that, that's fine. Doesn't really matter. And that's a positive moment about D. And then you got the 350 Newton force at 20-degree angle. I would just break that up. I would break it up into a horizontal and vertical. Okay. Let's take a look at the vertical. Okay. The vertical force that's applied at the brake pedal is going to be 350 times the sine of 20 degrees. Okay. And its perpendicular distance to D is 20 millimeters. Okay. And it creates a negative moment about D, so it's going to be negative. And also the horizontal force is 350 cosine 20 degrees, okay? And it has a perpendicular distance to D of 70 millimeters, okay? And it is also negative about D, and that equals 0. So that enables you to direct solve for F, okay? Oftentimes, a good moment equation can get you the solution you need. Now, of course, in this problem, it doesn't just ask you for the force at the spring, which is F. It also asks for the pin at D, the forces at D, okay? So that's a pin. So in order to get those forces, you're going to have to write some forces in the x equals 0 and some forces in the y equals 0. And I'll write that out for you just for completeness. The sum of the forces in the x direction equals 0 is going to say this. It's going to say, I'm going to say right being positive. It's going to say minus f plus dx minus 350 cosine 20 equals 0. And the y direction, up being positive, you're going to have dy minus 350 sine 20 degrees equals 0. Since you already know what f is, you got that, you can easily solve for dx in the top equation, and you can easily solve for dy in the bottom equation. So that's just a quick example of a 2D problem. Don't forget about the 3D problems, though. Look at your homework. Make sure you know how to do that for the 3D problem. But for the 2D problem, this should review your homework that you had last week, and just make sure you're comfortable drawing free body diagrams and moments. That's going to be really important for the 2D case. Again, don't forget about distributed loads. Don't forget about 3D moments, okay? Let me review everything here. Don't forget about setting up equivalent loads, okay, as well, all right? I think this is a test that you'll be able to do well in, okay? I really tried to set and make an easy test. I really did. I hope most of you walk out and go, that was easy, okay? But review those things. Make sure you know how to do those things, and hopefully you can do well. All right, good luck.